Hello all, I'm Dr. C. Jenny Tenancy, Assistant Professor, Department of Mathematics, PPG College of Arts and Science, Coimbatore. We are going to see simulation today. What is simulation? It refers to the imitation or reproduction of a real-world process, system or phenomenon over time, typically in a controlled environment. It involves creating a model or digital representation of something, maybe a process, environment, or a system, to study its behavior under different conditions. It can be used in various fields such as science, engineering, economics, medicine, and even video games to test theories, explore scenarios, train individuals, or predict future outcomes. Now comes some common types of simulations. Physical simulations. These imitate physical systems like a flight simulator that recreates the experience of flying an aircraft. Mathematical simulations. These use mathematical models to simulate behavior of complex systems such as weather prediction models or traffic flow simulations. Computer simulations. These use computers to model systems and processes like simulations of ecosystems, stock market behavior, or even virtual worlds in video games. The uses of simulation, training and education. Simulations are widely used to train individuals in high-risk or complex environments without the associated dangers or costs. For example, flight simulators allow pilots to practice flying without leaving the ground, and medical simulations enable healthcare professionals to perform surgeries or respond to medical emergencies virtually. Testing and experimentation. Simulations provide a safe way to test theories or experiment with systems without real-world consequences. In engineering, simulations can test how structures will react to stress or natural disasters such as earthquakes and floods before they are built. This helps in refining designs and preventing failures. Predicting outcomes and decision making. Simulations are used to predict future outcomes by modeling various scenarios. For instance, in economics or finance, simulations can forecast market trends, assess risk, or help in making investment decisions. Similarly, climate simulations predict future weather patterns or the impact of climate change. Now comes the Monte Carlo simulation, which is a powerful technique used to model and understand the behavior of a system or process by running many simulations using random variables. This includes 6 key steps. First one is defining the problem or system. Clearly define the system or problem you're trying to model. This includes specifying the variables, relationships, and parameters that will be part of the simulation. For example, if you're modeling a financial portfolio, you will define the variables like asset returns, volatility, etc. The second step is defining the probability distributions. Determine the probability distributions for the input variables. These distributions describe how each variable can behave. For example, you might use normal distributions for stock returns or uniform distributions for random sampling of values. These distributions in turn will guide the random sampling process. Third, generate random inputs. Generate random values for each input variable based on the defined probability distributions. This is done repeatedly, often thousands or millions of times, to create a broad sample of possible outcomes. The randomness of inputs mimics real-world uncertainty. Perform a simulation or run the model. With the random input values, run the model to simulate the process or system. For each set of input values, calculate the corresponding output. For example, in a financial model, this might be calculating the future value of a portfolio based on random asset returns. The fifth step is analyzing the results. Once you have run a large number of simulations, collect and analyze the results. This typically involves creating a distribution of possible outcomes. Statistical measures such as mean, variance, percentiles, and confidence intervals can help summarize the results and offer insights. Finally, make decisions based on insights. Use the results from the simulation to make informed decisions. For example, if you're analyzing a risk model, you might use the outcomes to assess the likelihood of certain risks occurring or to evaluate different decision-making strategies under uncertainty. When do we use simulation? When testing is expensive or dangerous, when real-world experiments are impractical or impossible, when trying to predict future outcomes, when you need to optimize systems for training and skill development, when you want to test what-if scenarios to study complex systems, and when real-time data is needed. Now comes the advantages of simulation. Simulation offers several advantages, making it a valuable tool in various fields, namely risk-free experimentation, cost-effective, time efficiency, complex problem solving, ability to explore a wide range of scenarios, better decision making, training and skill development, optimization and visualization of outcomes. Thank you all.